Hello, I am Li Hao. Welcome back to the Build Your Own Svelte series. In this video series, we've learned how you can build a Svelte compiler. It starts with the one video that I basically did a talk to talk about how you can build your own Svelte. And from there, we extend further, not just writing a Svelte compiler that can parses, analyzes, and generates an optimized JavaScript code that runs on the client. We have added more features such that we can handle a reactive declarations, and also in the last video we've made it such that it can be also generate code that runs on the server. So for the server side, what we generate is a JavaScript function that returns a JavaScript string. So you can take that function and put it in any of your node server such that when there's a user request comes in, you can call the function, returns the string, and that will be a HTML string that returns to the browser. And your browser, when the browser sees the HTML, it parses and display the code, the HTML content in the browser. So let's take a quick look at what we have done over there, right? So this SSR JS is the function that our Svelte compiler generates. And if you have a server that basically calls this function whenever there's a request, and it writes it and return from the response, what you have is that, let me run this node server. What you have is a server. Whoops, sorry, port 8000. So what you have is a page that returns directly from the server. When you refresh, it's here. If you disable JavaScript, for example, you refresh and you still see this because this whole page is being rendered on the server. You don't need any JavaScript code, JavaScript to run in order to see your page content. However, because, let me re-enable our JavaScript, because JavaScript is not needed or it's not run on this on the client, basically all interactions is not available by the user through the browser, right? You can't interact. You can't click buttons and expect to update anything. So, but we have done that, right? We have figured out in our very first video, we have figured out how we can create a client-side JavaScript code that has all the reactivity. So we have the code that is generated for the client side, and then also we have the code that's generated for the server side. So how one is reactivity, one is run on the server side. So how do we put this together such that on the server it generates the HTML code, and the client side it just reuse the existing elements and put things together and reactivity, and then blah, boom, you have a perfect Svelte application. So how does that works? How does that happen? So let's take things a bit slow. Let's start with the basics. Okay. So here, this is our server that returns the generated string that returns from a function. If you take a look at the response, let me zoom it up a bit. Zoom. Okay, I think this is way much big and should be good enough. If you look at the network tab, let me, can I hide anything? Okay, nothing. Maybe a bit too big. Okay, I think this is just nice. We try to refresh, you'll see that this is a response that's written, and this is the HTML response that's come from a server. Something is missing here, which you don't see the HTML, the head, and the body and stuff like that. But you know, browser is very forgiving; it can still parses it. But what we want to add is add those, and also add the script tag so that we can run our JavaScript code in here as well. So how do we do that, right? So previously, this is our HTML that we have that we can that generates this that we run that only works on the client side. And now let's take this as a template and put it together with our server side code. So here, instead of writing just return directly the response from the server, we are going to include this HTML string over here as well. All right, so where do we put this in? I'm going to put it inside here, id equals app, so that we can find it easily later on. Okay, And after I put this together like this, this app should start from the app div element. Let me zoom it up a bit. So here I have document query selector app. Okay, so now let's restart our server and let's go back to our browser and refresh. Now this is more like it, where you have this and then you also run this script over here. Let's see. Now one thing we can't do is, okay, we failed to so if you look at all our server, even if you request for app.js, we are getting the whole HTML, because in this function we didn't really differentiate between whether it's what request it is, right? So here we need to handle that. So request.url. Let's see what is the request URL when the user makes. Hold on, let me run this again. Let's refresh. It goes to the slash, also slash app.js, and then also the favicon icon for this one. So I just want to handle specially for the app.js, which should return the content of this app.js files, and the rest I'm still returning this, just for this simple example that we have, right? So if request.url equals to this one, I am going to read the content of this file. So I'm going to need some function from here, fs read file sync, and this file I am going to need some helper to find the actual path it is. So this one is path.join current here where I am, and the slash app.js. And this is UTF-8, and this is the app.js content. And here I'm gonna write the file content directly, and that's it. We're gonna end it and we're gonna return. Okay, and I need to set the header as well. So the content type needs to be application text JavaScript. Let me restart and refresh. Hold on, their name is not defined. Oh, hold on. Let me figure out this one. I need to from file URL to path. Refresh and hold on, still have error. Oh, where's the error? Path must be a like do something wrong. File URL to path URL. And so this kind of works. Let's see what we have so far. So here, basically, we're gonna read the content from app.js, gonna make the full path. Here I am gonna use because this is a ESM module. We can not get the dir name. We're gonna use the import meta URL to get the current path file URL for this file module that we have currently, convert it to a path so that we can create this whole path, and then we're gonna read the content of it, and we're gonna return response by setting a header as JavaScript, write the content of this file, and then return, and that's it. So we're gonna handle specially for app.js, and the rest we're gonna return the HTML as a response. And as we run this, if you see, this both works. Localhost returns me a, how do I zoom it out a bit? Localhost returns me a HTML string. App.js returns me the whole JavaScript file, and that's what we need. And as we run, we realize that you have both the application on the screen right now. right? Because one is being rendered from the server, and if you can't click it, it's not interactive. And the second one is actually coming from the client-side code that just runs. Okay, so if you try to click on here, it is interactive. Right, so we have one code that being HTML is being generated from the server, not interactive. And on the other hand, we have when you run a JavaScript code, it will create all the elements from scratch again, and then that is interactive. What we need is actually a combination of both. You have content from the server, and then when we run JavaScript code, we want it to reuse the existing elements that has already been created out of the HTML response, right? Because when the browser receives the HTML response, it creates all the elements on the screen to display for those for the HTML that that's being returned, parse it and generate those elements. You have the DOM elements on the DOM already, your document object model, and now when you run your JavaScript code, it should find the relevant or that all the elements that it belongs to, that it should create, and reuse them, and then add event listeners or add interactivity to it so that it works. Okay, so this should be how it works. Of course, there are actually more to it than it meets the eye, because when you run the JavaScript code, when it tries to find the elements, there could possibly be three scenarios. One, there's no elements that you can find at all. In that case, we can safely assume that the server side is not rendering anything. The server just returns an empty page, and your code should build everything from scratch. Okay, that's case number one. Case number two is everything has already been generated by the server, and it matches perfectly so that you can find the exact right elements that you need, and you can exact elements that you need, and then it attach just to it and latch to it, and it just works. Okay, the last case scenario is the most headache scenario, which is that maybe the content that you have in the HTML that returns from the HTML, the DOM element that is built out from the HTML, does not look the same as what you have from the client-side code. That could arises by various reasons. Maybe there are some logics that runs on the server, and those informations are not available for the client side. So it sees the HTML the DOM element that tries to be created by the clients from a client side code is different from the HTML string that generates from the server side, and it does not match. And now the client side will have to figure a way to reconcile with it, and that's the worst case scenario, because now you will have to figure out how you should reconcile. Should you trust everything from a server side, or you trust everything from a client side? Of course, we should trust everything from a client side, right? But then extra elements that are being created from a server side, do we need to throw them away, discard them, or what should we do with them, right? If it doesn't match, right? Should you recreate new nodes and attach to it, or and throw away the rest of whatever it's from the server that does not match? Or what's the strategy? Is it like the what if that extra nodes is in between or in the first node, and then you will have to, it does not match, you will trash everything away and then recreate everything, but actually the last three or the remaining are actually the same, right? There's a lot of things to consider over here, and there's no easy way to go about it. And in principle, we will have to figure a way to design our language in such a way that this case does not happen. It should happen only when the developer has configured something wrong, right? Which should be fixed, right? So you only repair it. You don't even repair. Then the best way is not to try to fix it. Which sometimes you call it like try to repair the DOM nodes that you have on that comes from the server, right? If you use other frameworks, maybe you will see that it will throw us warning on error that says like the content is mismatched, does not match to each other, and this couldn't proceed with this process. And this whole process, we call it the hydration process. Okay, I'm not sure if I realized that I just explained the whole process, but I forgot to give that the name. This process is called hydration, because it's like get the whole response, which you can assume that one analogy that I like the most is that you can assume, you can imagine that the whole response that comes from a server is like a dried pizza, right? And it got no interaction. You cannot have any reactivity. It does not work. It has all the looks, but it has no interactivity with it. So you can imagine like a pizza, but it's dried. Cannot bite into it because it's not nice. Like a frozen pizza. But so when you add JavaScript, client-side JavaScript code, it's like adding water to it so that it hydrates the pizza so that it is nice and fluffy and can you bite into it and very tasty, right? So this process is trying to, you already have the looks of it, but now you add more, make it edible. Okay, so the hydration process is this whole process, and today we're gonna figure out how we can make our Svelte, our own Svelte, to be able to do this hydration process. And to make things simple, we're gonna not consider a third scenario, which is there will be a mismatch from the server and the client side. We just assume that it's either it's not there or it's there and it matches perfectly. Okay. So to do that, let's figure out how our app.js should look like, right? Same thing as what we have done all along. We always look at the code that it generates and then figure out how it should look like, so that we know how we can tweak our Svelte compiler such that it generates the code that it works as we expect it. So here we're gonna make some changes to app.js, and we're gonna look at how it affects how it interacts in the code in our application, right? So here, one thing that we definitely need to take care of or figure out is that we no longer can do the create element, right? Because you only create element when if we assume that it's either all or nothing, the server does not return anything or return something, then because we cannot always do create element. If it returns nothing, then we always do create element. If it does not return anything, then what we do is we are going to you reuse the existing elements. Okay, so here first is we need to have a way to figure out whether we need to create or we need to create the elements, or we need to we need to create an element, or we need to just reuse the existing elements. So here maybe we have a check over here. So for example, I'm gonna call that flag is hydrating equals to so we check the targets. If it's greater than 0, then we're gonna say that we are going to do hydration, right? A better way, should hydrate. Okay, so let's take a look at what is this value right now when we run. Right, if we refresh, you will see that the child nodes should hydrate is true, because the child node, there's a lot of there's children that we should reuse. And if we go to our server code and try to remove this, remove everything at all like this, if we don't render from the server side, and let's restart our server, you see that the should hydrate is false. So there's no existing elements that we can reuse. So we should not hydrate. We should create everything from scratch, right? So let's restore this, and because we need to figure out how we can hydrate it, right? So when should hydrate is true, we are not going to create elements anymore. We are going to reuse the elements, right? So how do we reuse the element? So we are going to reuse it by find the first element in this in the children list, right? So we probably will have to, if should hydrate, then we are going to take the first element, and instead of creating a new button like this, right? And the same thing as all the create element as well. So this one, right? So if should hydrate, I'm gonna take this and it's right instead, right? So it same goes with this one, and same goes with here like this, right? And also goes with all the buttons for 5. Okay. Let's take a look at how it feels right now. A bit messy, but at least some of the nodes are reused right now. Okay, except that we probably have screwed up something. But just to show you how we can reuse the element and not creating a new one, we can basically take the child nodes like this. But of course, we need to figure out a better way to do it. So hold on, let me revert this a bit. I definitely, you can see here, I have not fully planned out how it works, but let's go with the flow. Don't worry, we're gonna figure this out together. Okay, so to get the elements, we of course we can reuse it, and instead of um let me see, we'll reuse it, right? And one thing that you can see over here is that when you reuse the element, we are not going to append it again, so that it does. When you append a child, it will add at the end of the parent, and basically it will shuffle the order. That's why it seems like the order feels a bit off. So if we should hydrate, then if we are not hydrating, then only we add we not add the button like this. Okay, so if you refresh this, now you see that there's only one decrement button that was not created over here, right? Previously we have, if you forgot about how it looks like, this was how it was. You have 2 decrement, and if you have, if you do this, then you have only 1, right? We reuse that element, and if you click on this, it works. But of course, we need to reuse this part. They reuse as treat them as the same, and then we can reuse the buttons as well. Okay, so that's something that we need to um, change in our code. So let's do that, right? Hold on, let me go to our index.js. So now in our code, in last time we say we have a compile target that compiles the code to either for SSR or client side. I'm thinking that since we are testing the hydration, we're gonna compile both at the same time. If so that we can always we generate the code both at the same time. So that when we make some changes to a component, we can see both of them updated together, right? So here I'm gonna comment this. I'm gonna remove this later on, but basically we're gonna write into 2 different files. One is the SSR, one is the app.js, right? One is for our client side, one is for our server side. And here in our generate SSR, this is for the SSR code, so it's here, and this is for the client side. This is going to go here, and I'm gonna remove this code, and this is what we're gonna build when we run our compiler. And in our generate code, this part, so just now when we look at our elements, we are basically saying that we need to, let me open it up. We need to check whether we should hydrate, and then we do this, right? Check the hydrate and then reuse the existing nodes from the targets, right? So basically here we can do that in our, before we start everything, we are going to push one more thing into this creates here. I'm going to add this line of code, like this, or actually we can actually put it in the create as well, create lifecycle here, like this one, should hydrate. And then in our create, in our elements, whenever we see any elements, we are going to check if we should hydrate, then we're going to use the nodes, right, from the parent, or else we're going to create a new one. So basically it's here. We're going to check. Target.child nodes. So this index, we need to figure out what is it. But here, when we are going to append the child, we are going to check if not should hydrate, only we're going to append our child, right? So here, let's try to build our code. Let me start another terminal node index.js. Right, as we build our code, so now you'll see that we do not reuse, we kind of reuse the existing elements such that this is being, something is wrong with the code. Hold on, let me take a look. What is the generated code look like? They all use the 0th element. That's why it's a bit weird. Hold on, we need to figure out what's the index. But basically you've seen that we are not creating new elements anymore, and we are reusing the existing button elements that's being returned from the server, which is a good start, right? So here, what is the index? Okay, the index, basically, we are going to start from, let's see. Okay, so when we traverse our tree, we always goes from top to bottom, right? That's how you see that the button starts with 1, 2, 3, 4, 5, 6, 7, and 8, and stuff like that, right? So maybe we can add a index over here. And then this will be our index, right? Index plus plus. And let's try run that and see what it works. Yeah, it's kind of work, right? Now we have buttons, and if as you run them, it does interact, right? Except that over here we kind of that's because if you take a look at the component that we have all the div. These are all reused, right? These are all button div button. They are all reused, except that the content, the text elements, we are still creating new text elements. Let me show you how it looks like in the end. Where's the app.js? Here, we have already reused existing elements like buttons and the divs and stuff like that. But in our text element, we still create new text element. That's why we have not reused the existing text elements, and we are creating them from again, like here, right? But we are close there. Let's see what we can do next. So just to show you that this, if we don't return anything from the server, for example, if we remove this and restart the server, if we restart the server, you see that everything's, if we don't have existing elements, then we just create elements from scratch, and you have perfectly nicely working application, right? So we only reuse existing elements when it's there. Okay, so let's get back to our code and see how we can reuse the text elements. So for text elements, I think it's the same, right? To instead of create elements, we're gonna reuse the existing elements. But the text elements is actually a child node of the button, right? So here we always say child nodes of the target, but we actually need the child node of the parent, which is the button. We need to get the nodes of the button. Okay, so we need variables to represent what is the parent, and also variables to represent what is the index. So to do that, here we can come back to our code. We need to also have variables that represent the parent, and parent by default is target right now. Okay, so here we are gonna replace this with the parent. Okay, and then hold on. Oh, this conflicts. So I'm gonna say hydration parent. Okay, this is hydration index. And once you're in element, before you go to the children, we're gonna update the parent to something else, right? So the parent now, so we're gonna set the hydration parent into something else, which is the variable name, right? And also the hydration index is gonna be 0, because we're gonna start to find the nodes from the parent, start from 0. Right, but after we traverse through the children, we need to reset it, because or else your parent will always start with the variable name. So we need to reset it back to what it was previously, or else if you run this, you'll see that the code will look like this. Not sure you can see it. At first we are target, right? Target, and hold on. Oh, we haven't go to the text node. Let's create that, and you will see how it looks like. So for text node, the create is to get the hydration parent. Right, let me copy this. Should hydrate. Right, so this will get the parent, the right parent child nodes, right? And then later on, when we should hydrate a div, again we are still assuming we are the div as our parent, but actually this div is its parents is actually supposed to be the target, right? Not the div tree. So we need to restore the value back for the hydration parent. So to do that, we're gonna just store in a variable first. For example, let current hydration parent. And as we go down and we come back, then we just restore the value. Like this. Okay, we store the previous value, and then we reset it, and then after we finish all the children, we reset back the value. We restore back the value, right? So as we run this, and now this is oops, this is the code that we have right now. A bit hard to read, but you can see that now when you should hydrate, when you get nodes, we actually get back to the target nodes, right? Get back to the parent nodes. So let's try and refresh and see. Now it looks much better. Static nodes are text nodes are fine, except that nodes that is based on expression feels a bit weird. if we try to interact, one part of it is interactive, another part is not. Okay, so we need to reuse the expression for the text node that we just created. So for that, let's look at the node for expressions. Okay, so for expressions, we create text node. Here again, we are going to reuse the text node if it exists. Oh, hold on. It exists, so it should be looking something like this. And same thing here, we are going to say should hydrate. If not should hydrate, then we're gonna add a pen child, right? So let's run this again. And voila, except that we have errors, but if you try to click, no, it does not work at all. Okay, when you click, it just crashed. Couldn't expand child when it is not a node. What just happened? Okay, so what just happened is that one thing to show why this happens is that we can first take a look at the response, or first take a look at our component. Okay, this is our component over here, where basically over here the div has a counter, so one expression, some static text, and another expression. Okay, so this is our second div, right? And when we do hydration, something went wrong. That's why there's some errors. And what went wrong is that over here, let's in our second div, right? This one. When we do the hydration, when we try to reuse the node like this one, let's take a look at what is the child nodes of the div tree. And if we refresh, you notice that the child node is only one item. Instead, we assume there's three different child nodes for an expression, the static, and expressions. But actually, it only have one element, which is the text. Why? Well, the reason is that because the reason here is because when you let me refresh this. When you get the response, it looks like this from the perspective of the browser, and this is just one text, right? How does it know whether it has one or two or three texts? It to the browser, it seems like it's just one text with no expressions or nothing. It does not even know or have an idea of where is the expressions. That's why it just takes up the whole thing as the first node, and then for the second and third one is just undefined. It's not even a node, right? So that's why when you try to if you try to do something with it, it will throw an error, or it will not do whatever you want it to do. So what should we do about it? How we can break this node into smaller nodes? There's a few things you can do. Of course, one is that maybe in the client side, what you can do is you do some optimization so that instead of creating 3 text nodes for like one expression, like 1, 2, 3 as 3 different expressions, 3 different text node, you combine them into one text node so that you update this text node directly whenever either counter or double has changed, right? You can do this kind of optimization such that it will just treat it as one text node. So you just rehydrate that one text node. You don't have to there's only one text node you need, and there's only one text node that returns from the server. That is one way that you can do. An alternative approach is that we would need to figure a way to break the text node into multiple text nodes that can be seen by the browser through the HTML response that you created. And but how do you do that? Well, to do that, one way that you can do is that you can return something that is invisible from the user, so the user will just can't see, but actually to the browser it means something that, and also in that sense that it breaks the text node into multiple ones, right? And that kind of node that you can do is that maybe, for example, you can use a comments node. You can put a HTML comment in between the text. So in let me show you how it looks like. So for example, if you have the, hold on, let me copy this out and show it to you. Right, so this is the node, this is the element that returns from the whole HTML returns from the server, right? But if you make it such a way that you add some comments over here, some comments over here, right, something like this, then what the browser will see is that now this is no longer one text node, because it sees some text, some comments, some text, some comments, some text, right? So the browser actually will create 5 nodes, 5 children for this div. One for the text, one for the comment, one for the text, one for the comment, one for the text. So in the end, there's like 5 different nodes, right? So if you do it this way, then the browser, you'll be able to break down the text node to the browser. So how we can do that is, so we're probably going to try to do this. Okay, so here in our code, where we generate the SSR code, and when we see a text like this one, and we add string, we also want to add another string called comment. Okay, so to break up the text, into multiple smaller texts. Okay, so let me restart the server and let's rebuild this code. And now if you run the server again, you will see that now to the server, hold on, you have, looks like this now. Okay, you have some comments in between. So now if I try to print out, let me try to print out, where is the div tree? Okay, so if I try to print out the div tree, div tree child nodes, refresh, you will see that now I have 3 nodes, the text, comment, and text. Okay, so now I can actually know I need to take the 0 and the second, sorry, 0, the text, comment, and text. You need to take the text node. You need to know how to take the text node. The order, I think, is a bit screwed up, because I believe we've did some append child or something like that shifts the order. I believe it's something like that, but we can look into it later on. Okay, so one thing you notice that we need 3 text nodes, right? But we only have 2. That's because for the expressions, we have not added the comments as well. So in our code, not just text, expressions as well, we're gonna add this behind the expressions. So when I rebuild this, and I refresh, you will see that in the response, refresh, I have 1, right? You have multiple comments, so you have 1 text node, 2 text node, and 3 text node that's being separated by comments. Because if you can optimize it, figure out, analyze it, you don't need the extra comment on here. You only need the 2 in between. Okay, but I mean, this is just showing you how to do it. Improvement, optimization, you can try it on your own. Okay, so here, after we have done that, what we need to figure out is, when we do hydration, we need to figure out what are the where we can get these elements now, right? So hold on, I'm here, elements, the text and expressions, right? So for the text, we should, yeah, I've guessed it. I forgot to add this one when we append the text node. Right, you should always append a text, do it this way. So here, when we should hydrate, we'll take the child nodes, right? So this time around, we should be able to get the right text node, right? But then because we created extra comments, we're gonna just do like plus another time so that we get skipped forward for the comments nodes. Okay, and same thing with the expressions as well. We are going to skip forward for the comments node. For whenever we encounter expressions, and I think that's it. Let's try. Oh, sorry. Let me go to the next, another one. Let's build our code, and this is our newly built code, right? And we have seen like this one will start with 0, and then it will go to the second and the fourth one. Because we skipped ahead from the comments node, we know that every time there's text, we will skip the comment, and this as well. And if you refresh now, if you look console, there is no longer any errors that's being printed out, because if you take a look over here, we actually have probably get the right element nodes, and these are all the comments nodes that we skipped away, right? And if I try to click, it works, right? You finally hydrate the code, and so all existing codes all the existing elements, we have reused them, and if it's come from the server side, you will reuse them instead of recreating new elements. So how do you sure that this actually works, or do we not throw away existing elements and recreate new nodes after we start run our client-side code, right? So just to demonstrate, to show you that this actually works, I'm gonna in this module, what I'm gonna do is that I'm gonna set timeout of 10 seconds, okay? And in here, I'm gonna show you. I'm gonna print out like timeout. I'm gonna print out that for the first 10 seconds when we receive this page, I'm gonna click on it, find the elements and stuff like that, and show you that these elements are what is being created by the browser when it receives the HTML response. And 10 seconds later, let me, instead of doing that, let me just create this as a function, then we can actually control the timing ourselves, right? So we're gonna call hydrate equals to a function. Okay, so when we run this script later on, when the server return the response, we have not done this, right? We will not be able to run this because this is just a function that is in the window object. So nothing happens. What we have is the HTML response received by the browser and use it to be render the page that you can see on the screen. So so you can't do any interactions. There's no reactivity whatsoever, right? And I'm gonna show you. I'm gonna find the elements, and I'm gonna show you that later on when I run window.hydrate, which is this function, which will create our application, run our client-side application code. And basically what it does, it will hydrate, basically will find the respective elements that's being rendered from the server, created from the server, attach event listeners, add reactivity and stuff like that. I'm going to show you that now it is interactive, and also it reuses the existing elements. It does not create new elements. Okay, that's what I'm going to show you, right? So let me restart our server so that it returns this new piece of code. Right, so this is returned from the server. When I click, it's not interactive, nothing happens. Okay, and these are all the elements that's being created because when we make our request, this is what returns from the server. So the browser sees this HTML and prints and renders this whole page out, right? And what I need to do next is that I'm gonna find some elements, like for example this one. I'm gonna assign it to a variable to a global variable. So I'm gonna do that by right click it and store as global variable over here. If you use Chrome, this you can see that temp1 now points to this element. Right, I'm gonna do it for a few more elements. I'm gonna come here, find this text node. I'm gonna this is the full, right? I'm gonna store as global variable. So I have temp2 is pointing in this area. Now after we store the references, just so that later on we can make sure that it points, it is the same exact element before and after the hydration, right? So now I'm gonna call window dot hydrate, call this function, boom. I should have shown this as together so that you can see that if something changes, it actually flashes in the elements panel that you modify the DOM elements. But because let's assume that nothing happens, so you can't see anything either way. Now we interact with the elements. It's working, fully working, and the temp1 we can still see that this buttons on when I hover, it still flashes up in the screen, meaning that this button one that we were storing in our temp1 variable just now that we just stored, still referencing the same elements on the screen, meaning the browser has reused, your code has reused the same elements. That's why it's showing up. If it's not, then you hover this, you can still find this button, but it's not on the DOM anymore. It's somewhere else. It's in the memory somewhere else. And same goes with this temp2, right? This text node, it's still on the screen, exactly where it was previously. So we reused this element. We did not do anything. We did not throw it away. And we have reused that element as we run our client-side code, right? So this is the hydration logic, where basically on the server side, you returned the whole, you render the whole page in HTML. The browser displays it on the screen. And when the client-side code comes in, it reuses existing elements, add reactivity so that it's interactive, right? And before the client-side code runs, basically you have the whole looks and contents, all the field is there, but it's just not interactive, right? If you have links, you can still go to everywhere else, but if you have buttons that has interactivity that needs JavaScript code to run, then those are not available, right? So there you have it. You have hydration, and that's how you create a framework that it works on both server side and client side, and put together both of them together with a hydration solution. So there it is. Of course, if you look and squint into this code, you may think that there's a lot of places that can be optimized, because we have repeated ourselves a lot of time over here that can be optimized. You can extract them out as a helper function that you can keep calling the helper function instead of having all this printed out in have part of your output JavaScript code. But that I leave it to you as an exercise. And this is it, the end of the whole build your own Svelte series. We've started from just a client-side Svelte compiler that parses, analyzes, and generates client-side code, to explore a few more features of a Svelte compiler, to we figure out how we can use the same compiler logic but then generates code for the server side. And then this video we see how we can put both together, the server side and client side, into a hydration a framework that can do hydration. And I wish you have learned a lot along with me through this build your own Svelte series. And that's it for my build your own Svelte series. If you like this video, give me a huge thumbs up. And if you like this kind of content, like build your own something kind of series, do let me know in the comment below. Tell me what kind of content you like. It means a lot, and I will try my best to create those videos. Of course, there are a lot of comments that tells me you want to see this, you want to see that, but not everything I'm confident enough to share with you. So do understand that. But I'll try my best to create videos so that both of us can learn together, right? And last but not the least, please do subscribe to my channel, because I am very surface person. I just like more numbers, because I don't know how I'm being brainwashed that more subscribers means better YouTube channel. But I believe some of you believe that, right? So please tell me in this way such that that my video is amazing and I have a lot of subscribers. So see you in the next one. Bye bye.